LeetCode 238, the product of array except self. So do you know this thing? We have multiple countries or multiple people and they're all allowed to multiply in between themselves except for one that we don't allow him to multiply with the others. So let's say we have a bunch of countries or people and we allow everyone up to index I to multiply between themselves, and index I we leave it as is, and I plus 1, and until the end of the people, the countries, the list, we allow them also to multiply, and we multiply it also by the first half. So everyone are allowed to multiply except for one that we don't allow him to multiply. So this is what this question is asking. It's saying, look at index I, allow everyone else to have fun and multiply, and don't allow index I to have any fun to multiply with the others. What is the result? And put this result in index I. Let's take the example from 238, the actual question on LeetCode. The input is 1, 2, 3, 4, and the output is 24, 12, 8, 6. Why is the first item 1 replaced by 24? The reason is that we allowed everyone except for one to have fun and to multiply. So we multiplied, it was the first number was 1, so we replace it by 2 times 3 times 4, because we had 2, 3 and 4 on the other indexes. If we would have 5 on the other indexes, we would multiply 2 times 3 times 5. Whatever everyone else, they multiply. Whatever you are, you don't multiply, because you are at the index I, and we need to replace all items at each index by the multiplication of all others. So 3 ways to solve it. One, the naive one, just go over each index and multiply everyone else and put the result on this index, or on a new array actually. Create a new array, because if we override the original array, we won't be able to calculate the other multiplications. Create a new array of num size, loop over the original array, multiply everyone before this index and after this index, put the result on the new array. The problem with that is that this would be O of n squared. The other way to solve it is going to have an O of n time complexity, but it's also going to have O of n space complexity. A follow-up question would be reduce the space complexity to 1. So the key to this second solution is called prefix and suffix. I like to call it the so far pattern. What does it mean? Let's create 2 new arrays. One will calculate all the prefixes, all the so far multiplications of all the people in the 4. So we let people number 0 to have fun, then we let person number 0 and 1 to have fun and multiply, and then we allow 0, 1 and 2 to have fun, and each time we put the result on a new array. So this would calculate only the prefix, only the so far from the left side. The same way we have another array, a second new array, where we calculate the suffix or the so far from the right side. So we allow person number n-1 to have fun, then person minus n1 and n-2 to multiply, then n-1, n-2 and n-3. Basically we are going to have 2 loops. We are going to have 2 loops. One loop we create the prefix or the so far from the left side of multiplications up until index I, each and every index I, right? And it's going to be easy to calculate it, because the multiplication up until index I is going to be the multiplication of I minus 2 times I minus 1, and I minus 2 we already calculated, so we don't need to recalculate. So this is going to be O of n. And then once we have it, the output of each and every index I is going to be the prefix at index I times the suffix at index I, and that's it. For the third way, we are going to even make it even more efficient with a decreased space complexity. Okay, so for the third way, we have this trick. We use the same array. So the key is that we are still going to create the output array. We are just not going to create intermediate array of suffixes and prefixes. So we are still going to create an output array. But on this output array, it's enough that we calculate either the suffixes or the prefixes. So let's say that we go over loop once on the output array, calculate only the suffixes. And then we still have the input array, right? And we have only the output array already with the fast suffixes. So we don't create suffix array, a prefix array, or have found from the left array, have found from the right array. We create only an output array. The output array will already be the have fun array, the suffix or the prefix array. And then we're going to scan this output array from the other side and multiply it by the input array and store the prefix. If we calculated the suffix array on the output array, then what we need next time is just a single variable each time we scan the array from the left. Okay, so created the suffix array on the output array. We now scan the new array, the input array from the left side. For each item, we calculate the prefix, we multiply it by the input array and put it on the output array. We can now just override the output array. Then we move on to the next item on the output array. We already have the suffix because it's on the right side. We already have the prefix, just multiply it by the previous item, save it as a variable, and in this way continue to calculate the output array. So the solution to the LeetCode 238 product of array is 1. Brute force for each item, multiply every item except for the single item. 2. Calculate suffix and prefix arrays, 2 separate arrays, and then from them calculate the output array. 3. It's enough to just have the output array, calculate on it, inside it, either the suffix or the prefix arrays, and then scan from the other side and in a variable put the prefix or the suffix, and then calculate the output array. So this was LeetCode 238 product of array except self without using division.